Hidden in plain sight, etched into the very fabric of our planet, lie the scars of ancient cosmic encounters. These scars, often overlooked, tell a story of celestial collisions that have shaped the Earth as we know it today. These are the impact structures, silent witnesses to the tumultuous early history of our solar system. Each crater, each formation, is a chapter in the grand narrative of our planet's past, a testament to the violent forces that once roamed our cosmic neighborhood. Today, we journey to one such scar, the Dhala impact structure in India, a place where the whispers of a long-ago catastrophe are etched in stone. This site, though weathered by time, still holds the echoes of an event that forever altered the landscape. Located in the heart of India, the Dhala structure is a relatively recent discovery in the world of impact science. Despite its recent identification, it has quickly become a focal point for researchers eager to understand the dynamics of ancient impacts. It lies nestled within the ancient Bundelkhand craton, a vast expanse of rock that has stood the test of time for billions of years. This craton, one of the oldest geological formations on Earth, provides a unique backdrop for studying the Dhala impact. This makes Dhala particularly intriguing, as it offers a window into the impact history of one of Earth's oldest geological provinces. The rocks here are like pages in a history book, each layer revealing secrets of the past. The Dhala structure, while eroded over eons, still bears the unmistakable fingerprints of a powerful impact event. These features, though softened by time, are a testament to the immense forces that once acted upon this region. These fingerprints, known as shock metamorphic features, are found in the rocks surrounding the impact site. They are the result of the intense pressures and temperatures generated during the impact, conditions that are rarely seen on Earth. They are the telltale signs of the immense pressures and temperatures generated during the impact, conditions so extreme that they can transform ordinary rocks into exotic new forms. These transformed rocks provide invaluable clues to the nature of the impact event. Join me as we delve into the heart of the Dhala impact structure, exploring its secrets and unraveling the story of its formation. Our journey will take us through the rugged terrain, where each rock and crevice holds a piece of the puzzle. Along the way, we'll uncover the fascinating world of shock metamorphism, a process that alters the very fabric of rocks under extreme conditions. This phenomenon is a key to understanding the forces at play during an impact event. Learn about the enigmatic tektites, mysterious glassy objects formed from the molten debris of an impact. These tektites are scattered across the landscape, each one a relic of the fiery aftermath of the collision, and discover how impact events like the one that created Dhala have shaped the very face of our planet. These events, though rare, have had profound effects on Earth's geological and biological history, influencing everything from the formation of continents to the evolution of life itself. Imagine a force so powerful that it can instantaneously vaporize rock, melt sand into glass, and transform the very landscape in the blink of an eye. This force leaves an indelible mark on the Earth's crust, creating features that tell a story of unimaginable power and destruction. That force is an asteroid impact, and the Dhala impact structure in India bears witness to its awesome power. This massive crater, spanning several kilometers, is a testament to the cataclysmic event that occurred millions of years ago. The rocks at Dhala speak a silent language, one written in the distorted structures of their very atoms. These rocks have been forever changed, their internal structures altered by the immense pressures and temperatures generated by the impact. These are the shock metamorphic features formed when the immense pressure wave from the impact ripped through the ground. The pressure wave travels at incredible speeds, compressing and heating the rocks in its path. Shatter cones with their distinctive horsetail patterns are perhaps the most iconic of these features. These conical structures are formed by the intense pressures of the shock wave, creating a unique pattern that is unmistakable. But the story doesn't end there. The impact also creates a variety of other shock features that provide valuable clues about the event. Planar deformation features, or PDFs, are microscopic imperfections in the crystal structure of minerals, like quartz. These tiny planar fractures are created by the passage of the shock wave, and they tell of the immense forces at play on an atomic level. And then there are the feather features, or FFs, tiny planar fractures that crisscross mineral grains. These features are further evidence of the intense stresses the rocks endured during the impact. These shock features are not mere curiosities, they are the Rosetta Stone of impact science. By studying them, scientists can unlock the secrets of past impact events and gain a deeper understanding of the forces that have shaped our planet. By studying these features, we can reconstruct the impact event in remarkable detail. Scientists can estimate the size of the impactor, its velocity, and the energy released upon impact. This information helps us understand not only the specific event, but also the broader processes that govern planetary formation and evolution. Each shattered cone, each microscopic PDF, is a piece of the puzzle, helping us to understand the violent forces that have shaped our planet. These features are like breadcrumbs, leading us back to the moment of impact and allowing us to piece together the story of our planet's dynamic history. In the aftermath of the Dhala impact, the skies above must have been a scene of unimaginable chaos. As the impact shockwave spread outward, it ejected vast quantities of molten rock into the atmosphere. This molten material, cooling rapidly as it traveled through the air, solidified into strange glassy objects known as tektites. Tektites are found in strewn fields, sometimes thousands of kilometers from their impact source, testament to the violence of the events that created them. They come in a variety of shapes and sizes, from aerodynamic teardrops to irregular button-like forms. Their colors range from jet black to translucent green, depending on their composition and the conditions under which they cooled. The presence of tektites associated with the Dhala structure provides further confirmation of its impact origin. These glassy messengers from the sky offer valuable clues about the composition of the impactor and the dynamics of the impact event itself. By analyzing their chemical makeup and isotopic signatures, scientists can learn about the materials that were vaporized and ejected during the impact. Tektites are not just scientific curiosities, they are tangible reminders of the powerful forces that have shaped our planet. They are pieces of the sky, forever linked to the cataclysmic events that brought them to Earth. The Dhala impact structure, though eroded over time, still bears the hallmarks of its violent birth. This ancient geological feature, located in India, is a testament to the dynamic and often violent processes that have shaped our planet over billions of years. Despite the ravages of time, the Dhala structure continues to intrigue scientists and geologists alike, offering a window into Earth's tumultuous past. Geophysical surveys and detailed geological mapping have allowed scientists to piece together the structure's anatomy, revealing a complex and fascinating story of impact and recovery. These surveys involve meticulous fieldwork, where geologists brave rugged terrains to collect samples and data. Back in the lab, scientists analyze this data, using advanced technology to reconstruct the events that led to the formation of the Dhala structure. The structure itself is relatively small, with an estimated diameter of about 2 kilometers. This may seem modest compared to some of the larger impact craters found on Earth and other planetary bodies, but its significance cannot be overstated. The Dhala structure provides a unique opportunity to study the effects of impact events on a smaller scale, offering insights that can be applied to understanding larger craters. However, don't let its size fool you. The Dhala impact was a cataclysmic event, releasing an enormous amount of energy. The impactor, likely a meteorite, struck the Earth with such force that it created a shockwave powerful enough to alter the landscape for kilometers around. The energy released during the impact was immense, equivalent to thousands of atomic bombs detonating simultaneously. This comparison helps us grasp the sheer magnitude of the event. The explosion would have generated intense heat and pressure, vaporizing the impactor and a significant portion of the Earth's crust at the point of impact. The impact shockwave would have spread outward with incredible speed, instantly transforming the landscape for kilometers around. This shockwave would have caused widespread devastation, fracturing rocks and creating faults that are still visible today. The immediate aftermath of the impact would have been a scene of utter destruction, with the landscape forever altered. At the heart of the structure lies a central uplift. A dome-like feature formed as the Earth's crust rebounded in the moments after the impact. This central uplift is a common feature in larger impact craters and provides valuable information about the mechanics of impact events. The rebounding crust would have pushed upwards, creating a peak that is now a prominent feature of the Dhala structure. Surrounding the central uplift is a ring-shaped depression, the remnant of the impact crater itself. This ring marks the boundary of the crater and is a key feature in identifying and studying impact structures. The depression would have been formed by the collapse of the crater walls, creating a circular basin that has since been partially filled with sediments and eroded over time. The rocks within and around the crater are heavily fractured and faulted, a testament to the immense forces involved. These fractures and faults provide a record of the impact event, allowing scientists to study the stresses and pressures that were generated. By examining these features, geologists can reconstruct the sequence of events that occurred during and after the impact. The Dhala structure is a microcosm of impact processes, a natural laboratory where scientists can study the effects of these catastrophic events on Earth's crust. This site offers a unique opportunity to observe and analyze the results of an impact event in detail. By studying the Dhala structure, scientists can gain a better understanding of the processes that shape our planet and the role of impacts in Earth's geological history. By understanding the formation and evolution of impact structures like Dhala, we gain valuable insights into the role of impacts in shaping the surfaces of planets and moons throughout the solar system. These insights are crucial for understanding the history of our own planet, as well as the geological processes that have shaped other bodies in our solar system. The study of impact structures like Dhala helps us piece together the story of our solar system's dynamic and often violent past.